Good morning everyone. Thank you for joining us in this webinar today on sustainability in the manufacturing sector. We will start now. I will just briefly introduce myself and Rina in case you don't know us, and then we will go deep in this topic today. I'm Michela Mattia, I'm an industrial chemist and I work as a project manager in Rina, especially in the R&D European projects. If you know Rina, we are a company that provides service and consultancy for different types of companies. We are more than 5,000 colleagues located in 200 offices in 70 different countries. The thematic that we cover as a company are several. The main business unit that we have are energy and mobility, marine, certification, real estate and infrastructure, and industry. As you may know, we are very active in innovation and sustainability, and not only with service to the companies, but we are also very active in the participation of R&D projects. As you can see, we are the second top industrial participant in Horizon 2020, and we have more than 500 R&D projects delivered in the last 10 years of Rina. But now let's start with our topic of today, which is the sustainability in the manufacturing sector. I will start with a brief introduction about why for us it's so important to work on the sustainability of the manufacturing sector, which can be the benefit for a company to improve their sustainability. And then I will give the floor to my colleagues to present you different projects, different case studies, where we developed together with other companies innovative solutions for the sustainability in the manufacturing applied to different types of sector. The last, after all the projects, we will have a question session. You can use, there is a dedicated part for question, you can write it there, and we will answer to all the questions at the end. So, this slide is to show you why we think it's so important to address the sustainability in the manufacturing. The traditional manufacturing nowadays is responsible for more than 50% of the global resources consuming. And it's also responsible for a carbon emission equal to more than 20% of the global CO2 emission in the world. It's also generating a lot of tons of non-recyclable waste that annually are landfilled in our planet. The energy consumption related to the traditional manufacturing processes is equal to nearly 1/3 of the global energy consumption. It's also responsible for more than 20% of the global freshwater resources use. Seeing this number, you can see why it's so important to take action in this topic. But what do we mean when we say sustainable manufacturing? When we say sustainable manufacturing, we refer to all the practices that are needed to design, source, and deliver a product with the maximum amount of value, but keeping the minimum environmental impact. Sustainable practices should address all these issues, the climate change mitigation by reducing the greenhouse gas emission, the energy consumption, but also minimizing the material waste, optimizing the resource use in the processes, It's important to address a responsible consumption, to give to consumers eco-friendly products, and to be also compliant with all the laws and standards related to environment. But it's very important to focus also to the other aspect of sustainability. In order to be sustainable, a process, a product, need not only to be sustainable in an environmental point of view, but also should be economic viable and also social acceptable as a process or product. But the main topic, I think, is how the companies can benefit from the use of sustainable practice. The first benefit that a company can have is, of course, the cost saving derived from the reduced energy consumption, reduced resource use, but also the minimization of the waste that should be disposed at the end of the process. This practice will allow to have environmental preservation, contributing to an healthier world for everyone, but also to be compliant with all the regulation and environment, will give the opportunity to the company to respond to the increasing market demand of eco-conscious consumers that want eco-friendly products. Using sustainability in your company will give also a positive global reputation of your company, giving a positive image of the company. But we have also to consider that the world is changing, and the sustainability is becoming not anymore a choice for the companies. So this will allow also to be success in the future. As you know, often sustainability is also really connected to new innovation, new process, new product, and so this will open also new opportunities and competitive advantages for the companies. Also, as a last benefit for the company will be to address also the social responsibility. So let's now go in the case studies that we want to show you today. We will present to you different type of projects, case studies that address different sectors in the manufacturing. As you can see, the first three projects are related to the composite sector. The first two mainly in the automotive sector, the third one more in the wind power sector. The fourth project is related to also to wind offshore facilities, but more in the development of material solution. The fifth project is more an horizontal thematic that can be applied to different sectors and focus on the human-centered rapid reconfiguration of production and value chain. The last project is related to the heavy and destructive industry waste of this sector. So, I will present the first project, which is Tool for Life, and then I will give the floor to my colleagues to describe the other project. As I told before, Tool for Life is a project related to composites, and it received funds from European Union under the program LIFE. The title of this project is Tooling Materials, Design and Process Engineering, leading to improved sustainability and wider applications for the composites of tomorrow. When we talk about composites, we can talk about different sectors and applications. Due to their properties, they can be applied to different end use. For example, automotive, aeronautics, space, nautical sector. This because they are very light material, but allow to have a very high mechanical performances. But what is the problem of the composite? Especially the sustainability of these products. Usually, they cannot be recycled due to the use of thermosetting materials for their production. What we want to achieve with Tools for Life? Tools for Life want to address the issue of sustainability in a pre-processing step, the application of tooling as mold for the composite manufacturing. If we consider nowadays, more than 95% of the tooling are made with thermosetting materials such as polyurethanes, and it corresponds to more than 2,000 tons per year of materials that are landfilled, so only in Italy. This project is coordinated by Bercella, an Italian company working on the transformation of composite material. For this project, especially in the automotive, we have Marbo, which is a chemical industry that will work in this project on the production of new sealant for this process. Centex Bell, which is a research center that will work on the development of the polymer, and of course we are also involved in this project. The project is located in Varano de' Melegrari, where we will have the demo of the plant in Bercella facility. The budget that we have for this project is around 3.5 million. And it will last for 3 years. It already started last year, so we have 2 years to go more. When we want to produce a composite product, before having the final product, we need to produce before a master model. This master model will be used to produce a mold that finally is used to produce the final product. With Tools for Life, we want to work on this first step, the production of the master model. We want to transform the tooling design and the manufacturing method of the master model in order to not modify the final performance of the composite product, but reducing the overall cost, reducing the impact of the process, but having a process that is easily incorporated in the traditional production of the composite product. The objective that we want to achieve with Tools for Life are to develop, adapt, and demonstrate an hybrid technology made of additive manufacturing plus milling for the production of the tooling that will be used for the final product. We foresee to reduce up to 80% the volume of the material used in the process, to cut the energy consumption by 33% and to reach a target of 9.2% of CO2 equivalent emission respect to the traditional process. We want to develop a new process that is fully retrofittable, and the final product, so the tooling that we will have, will be completely recyclable for producing a new process, a new product, new tooling. This will be done going from a thermosetting material to a thermoplastic material mainly. Which are the impacts that we want to achieve with Tools for Life? I want to give you some numbers of what we are expecting to achieve. Let's say, when we talk about waste production, we foresee to reduce the waste production at the end of the project of more than 30 tons per year. When we take in consideration also our replication strategy, so what we want to achieve in the medium term, more or less 5 years after the end of the project, we foresee to have a reduction of the waste production that will be around 200 tons per year. We will reach also an energy saving thanks to the use of additive manufacturing respect to the machining of the tooling, which is the process that is used now, that will be equal to 18 megawatt-hour per year at the end of the project, and hopefully equal to 120 megawatt-hour per year at medium term. It will allow also this new process will allow also the elimination of the use of toxic chemicals that are now used in the production of thermostatic materials. An example is the use of isocyanates in the production of polyurethane, that is the most used material now. And this elimination will be around 20 tons per year at the end of the project, and in the medium long term it will arrive to an elimination of toxic chemicals equal to 130 tons per year. Tools for Life will allow also to reduce the CO2 equivalent emission and reach a emission of CO2 equivalent for unit for tooling equal to 63 kilograms. It, of course, will allow also to generate new business and increase the new job opportunities in the sector. When we talk about Tools for Life, it can be placed in the European landscape fully compliant with the objective of the Green Deal. In fact, I report in this slide some objectives of the Green Deal, such as the industrial mobilization for a green and circular economy, the zero pollution, toxic-free environment, and how we will help to reach this objective, this European objective. We will help reducing the carbon footprint of our process. We will help reducing the waste production, but also the removing the use of toxic chemicals. This slide shows how we want to achieve this, the results of Tools for Life. The first step, which actually is already done because we are already in the second year of the project, is the identification of the best thermoplastic material or mix of materials that is being done by Centex Bell. The second step will be to identify which are a good formulation of water-based sealant that will go to substitute the solvent-based sealant that is traditionally used in the production of tooling. Marbo will also work on the development of in-mold coating, more sustainable with respect to the coating used now. Centex Bell will work also in the optimization of the process of recycling, studying how the properties of the material changes during the recycle, also how many times we can recycle the materials, how much virgin material we need to add to the process, and etc. Rina is working on the optimization of the process in a topological point of view. This to reach the minimum amount of raw material to use in the additive manufacturing to produce the tooling. Bercella is working on the assessment of the demo. They already put in place the demo in their facilities and will test the overall process and the recycling process. All of these will be followed by an environmental, economic, and societal sustainability assessment of the overall process. The methodology that I showed you now is divided mainly in 4 steps. The first step, which is already done, is the equipment design and commissioning. The second step will be the tooling manufacturing operation. And the third step will be the tooling decommissioning and recycling. So at the end of the life, the tooling will be recycled, and we will test also the production of new tooling using that material. And at the fourth step, we will have the sustainability assessment. The results that we will have, the process that we'll reach, will be almost ready to a TRL, commercial TRL. So when we talk about the replication strategy that we have after the end of the project, we are planning to use this process at the end of the project to substitute completely the production in Vercella, but to achieve also the production of tooling as a service for other companies using this process. And at long term, what we would like to achieve is to spread this new technology, more sustainable technology, to make also other producers similar to Vercella to use this new technology, licensing, of course, the technology. I want to leave you with a last slide about the next event where 2for-Life will be presented. In case you want to know more, there is this breakfast session organized by one of our partners, Sentexbel in Belgium, that is related to 3D printing of waste materials. You can find the registration link below. So I thank you for listening to 2for-Life. Here you can find my emails and the website. In case you have questions, of course you can do it now, but also contact me. I will now leave the floor to my colleague Teresa to present Zero Waste Life.
Thanks,
Teresa, the floor is yours. Thank you.
Yeah, thanks, Michela. Good morning, everybody. So I will proceed with a project that is quite the prosecution of Michela's project, and as a matter of fact, the coordinator of the project is the same, is the Vercella company. The project Zero Waste Life is a project that has been funded under the Life Program 2022. And in fact, the project started just on July 1st, 2023. The objective of the project is differently from the case of Michela, in which tools for preparing pieces were made, is preparing the pieces in this case through an optimized process that is going to improve the sustainability, the global sustainability of the production of composite. Going into the depth of the project, essentially, as Michela said before, we know which are the main issues on material composite that essentially rely on the difficulty to recycle composite. Generally, they are treated by pyrolysis, so they are incinerated, creating CO2 emission and chemicals emission, or they are wasted, landfilled, and treated by chemical routes. The idea of this project, the Zero Waste Life project, as a prosecution of the first one, is to create more sustainable pieces operating with a dual approach. The first approach is on the manufacturing process. In this project, we present a new manufacturing process that is called high volume tailor fiber placement. Essentially, this process that is a patent process by Nobrak company, that is a startup company working on composite material, relies on the stitching of composite filaments on a flat pattern. It's quite something between a sewing machine and a 3D printer to understand this. So the possibility to put the material, to deposit the material just in the place in which the material is needed, obviously led us to a reduction of the raw material at the beginning of the process. And another aspect of this process is that the H-Wood this treatment allow to create a modular design. That means create some basic elements that can be treated after that with the moulding process, and eventually reused. The pieces can be reused with a further reduction of the material employed and all what is related to their production. Okay, just to give a more in-depth view of the project, as Michela showed before, the first step also in this case will be the consolidation of the design shapes, essentially to optimize with theoretical calculation the shape of the pieces to produce, with the idea to bring the waste to ideally zero waste results. Then a design of the part of the basic element will follow that essentially are made of beams, plates and shells that can be combined to create future complex products. A further step will be the demonstration of this product in a real case study, in particularly producing pieces for automotive and aerospace application. And finally, at the end of the project, we are thinking to there is an exploitation and IPR strategy management, also to create awareness around the initiative of the project, and more than that, to increase the industrial attractiveness towards this new patent technology, towards this new process that is brought by Nobrak's partner. In terms of expected impact, as you probably know, the LIFE program, the LIFE program addresses several environmental topics, and the topics to which Zero Waste Life belongs to is the circular economy and quality of life sub-program. This program aims at facilitating the transition towards a circular economy, a sustainable economy, and also a toxic-free environment. And in this sense, the Zero Waste Life process addresses several issues, several objective in relation to the sub-program, because essentially what is expected from the project is the reduction of landfill material, because the process requires thermoplastics materials instead of thermosetting material, as Michela said before. That means also reducing the non-renewable materials, again, because thermosetting resins are not recyclable at all, while thermoplastic materials can be eventually reused and reused again. And overall, we expected a reduction of the energy production that is related to the for one side to the new process. because, as an example, in the process, the autoclave treatment that is very energy consumptive will be substituted by a different treatment, by a pressure treatment that reduces the energy required for the process. At the same time, we expect a reduction of CO2 emission due to the not waste materials, and also due to the reusability of some pieces that obviously don't need to be remade again. We also attempt to give a raw estimation of the quantitative impact of the projects, and the estimation also relying on the numbers of the previous project Tool for Life that materials show has been fixed around the values you can see in these slides. We expected more or less to save the 40% of raw material from landfilling, that more or less are 10 tons per year for Bercella's company, because this is the amount that the company brings to landfilling every year. We expect an energy saving of the 15% that results from the overall balance of the process, and from the possibility of reuse some parts due to the modularity of the pieces. And we expect a reduction of CO2 equivalent emissions of the 15%, again due to the avoided the wastes of raw materials, and to the global balance of the process. Okay, we made also some qualitative, some economical consideration, and obviously, as you can understand, avoiding to landfill materials brings with him two types of costs. First is there will be a reduction of the cost of material, and the second reduction of cost is related to the taxes, to the additional taxes that are generally related to the landfilling of material. Other cost reduction will be due essentially to the reduced energy consumption during the manufacturing and the reusability of the pieces. Also in this case, we attempt to make a quantitative estimation of the saving, and in terms of reduced materials and energy savings, that means an estimation on the production cost. More or less, the preliminary LCA analysis show us that this value can vary from 10 to 40%. This is a huge interval, and it is essentially due to the type of composite that is produced during the manufacturing process. Anyhow, we expect as a minimum value to reduce the production cost of the 10% of on the total cost production. 300,000 million euros, are the cost saving expected from the raw material that is not discarded at the beginning of the process, and 5,000 euros is expected for as a saving for the in terms of taxes that in other case will be spent for the disposal of the raw material. We also made some provision as of the impact on society of the project. Obviously, on the short term, what we expect is an improvement of the worker condition in the facilities that will implement the process, that is Bercella, and also eventually other facilities, other clients in which the process will be eventually implemented, and improvement of the quality of life in general of all citizens, thanks to the reduction of CO2 emission, thanks to the reduction of landfill and waste materials. in the long term, obviously, the provision is the possibility to increase workplace and opportunities for formation due essentially to the adoption of a new technology that is the one we saw before of stitching the filaments in the place in which essentially they are required. Also, Zero Waste Life, as the previous project, is compliant with some objective of the European Green Deal, and in particular with the concept of mobilizing industry for a clean and circular economy that is obtained by reducing energy consumption and CO2 emission, and also by reducing wastes and recycling the produced material once they are dismantled. Another objective that is addressed by the project is a zero pollution ambition for a toxic-free environment that essentially means in this case, means to avoid the CO2 footprint and obviously reducing pollution by reducing waste and landfilling of thermosetting material and composite materials in general. A third objective that is addressed by the Zero Waste Life project in relation to the European Green Deal is to accelerate the shift to a smart mobility. Obviously, this is an objective as we can say is addressed in indirect way because essentially the idea is that reducing the weight of materials and producing material composite that are known for their lightweight and for their stiffness at no compromise on their mechanical properties will mean for the automotive sector and also, for example, the aerospace sector to produce lightweight structures, and these obviously go towards a sustainable mobility, reducing eventually the cost for moving the cars, for moving the cars, and as a consequence the produced CO2 and so on. As the previous project, this project is organized in 3 main steps that essentially are based on the definition of the theoretical parameters and optimization of the design of the pieces and the process, the development of the technologies through the creation through the demonstration in two real case study in the automotive and aerospace sector, and finally an economic, environmental, and societal assessment will be made to validate the sustainability of the project in the case of automotive and aerospace application. So what we expect after the end of the project, our idea is that we can design 3 different levels of exploitation. The first level is for sure the internal exploitation of the new process by the company, by Bercella. That means reducing the cost of production and creating saving for the company itself. Eventually, the idea with the activity of dissemination and communication plan will be to reach out in the first years of the project new clients to produce limited series of the new composite. A second level of exploitation that is expected to come after the optimization and of the shapes and the design of new products, as an example, to address niche market for very specific application, is expected to be reached more or less at the end of the project, because we expect that after 3 years the process and the automotive parts in Pisa will be optimized at all in their shapes and can be eventually produced. A third level of exploitation is the one that we expected after the project ends, eventually from the first year and of the project end to for the following 5 years. That is the possibility to license the new technology to other manufacturer and selected composite producer. And this is obviously expected to increase the revenues for the companies, for Vercel and for all the partnership, as far as the business increases. Okay, that's all, and I want to thank you for your attention.
Thank you, Teresa, for your presentation. The next project that we will present is a project related to the wind power sector, Refresh, and it will be presented by the next speaker, Daniel Grisenti. Daniel, the floor is yours. I cannot hear you.
Now you can hear me?
Okay, now yes.
Okay. Okay, you can see the presentation also?
Yes.
Oh, okay, perfect. So, as I said before, I am the project coordinator for Refresh project, which stands for smart dismantling, sorting, and recycling of glass fiber reinforced composite from wind power sector through an holistic approach. This is the project acronym. The project is an innovation action, so the TRL expected is about 6 and 7. The main objective is to develop on large scale an industrial demonstration for the composite material recycling technologies from the wind blades to increase the circularity of the wind sector. So this is the main aim of the project. Now we'll move to the Refresh consortium to give you an overview of the partners. We have 11 different partners from 5 different countries. We count among the consortium waste recycling and remanufacturing companies, as GIS Recycling, which is located in Italy, STD, and MTB. We have engineering and consulting companies, as like Arena. We have some research and development companies like Sears and Setma. And we grant the access to stakeholders in the composite sector manufacturers with EUSIA, which is the European Association for Composite Materials, and also thanks to Acciona. And this consortium, Rina is the project coordinator, as said before. Now we'll detail a little bit better the objective of the project. So the general aim is to demonstrate the circular approach for the recycling of the fiber composite materials derived from the dismission of the wind turbines. So the first objectives are technical ones. So we aim to develop decommissioning and sorting technologies for the composite materials alongside with mechanical and thermal recycling for composite materials. This will lead in the development of new products with the high replacement of virgin raw materials with the recycled ones obtained from these recycling processes. Alongside with this, there will be the development of a blockchain tracking tool, which aims to manage the data of the recycled components and to assure the quality for the end-of-life composites. And this one, these objectives will lead to development also of a business plan for the eco design of the whole project solution. This is the concept through we aim to reach the above objectives. So the whole refresh concept is to start from the decommissioning of the wind blades and end with the end product ready for the market. So at the decommissioning of wind blades, the blockchain tool intervenes, getting the informations, technical information, composition information of the dismissed blade. Then the tool makes a market check to check the current market demand of end products. So once it made the market check, the technical check, environmental check, select the proper recycling process that is more suitable at the moment for that blade, for that business blade. So this is the business, which is a flexible one because it constantly can adapt to the market, the current market of the sector. So after the selection, based on the market demand, technical condition of the blade, there are the different recycling processes. As said before, mechanical recycling process and the thermochemical ones that are based on pyrolysis. There is also an option for the reuse of the composite material as is, for example, as a filler or something like this, or other processes that will be investigated through the process of the project development. And we have at the end refined end product ready for the market, because this was the real challenge for the project concept, because the material that compose wind blades is not so precious, we can say. So the fact is that the virgin raw material it's cheaper because it doesn't need any process to be recovered, so no energy waste, and okay, so it's cheaper and usually has a greater mechanical properties. So the need was to get an end product with an added value, because that added value makes the solution competitive. So this is the concept. Through the various recycling processes, we get end product with higher placement of virgin raw material, but we gain in the added value of the project of the products for the circular market. So the expected impacts, here there is some data on based on the penetration rate expected from the project end. So as said before, the main impact is the reduced use of virgin raw materials in terms of composite materials. So we have a lot of tons of product that could be replaced with our cycled materials. As said before, these data are based on a forecast assuming in the first 5 years from the project end, the penetration rate of the project in the market of 5% and have 12% by the next 8 years from the project end. Then we have an increased amount of recycled composite materials from wind power sectors, which amount for the glass fiber reinforced composite materials of 22 megatons in 5 years from project end, and 53 from 8 years from the project end. And lastly, but not least, this will result also in new job opportunities in the waste management sector, eco-design sector, also digital sector, because we have the digital part related to blockchain tracking tool, and the manufacturing sector. So, lastly, the exploitation perspective after project end. So we have different solutions developed by different partners. So as I said before, we start from the decommissioning. So we aim to develop a portable system for the dismantling and shredding of wind blades, because wind blades are logistically difficult to transport after the dismission. So we plan to have a portable system that can pre-treat the blades and make them more transportable to the recycling processes. Then we have the mechanical recycling with a technology and formulation for secondary raw materials recycling. For the thermal processes, as said before, we have generally pyrolysis systems, but one is assisted from microwave, and the other one with electrical pyrolysis. So in this case, we can also obtain the chemicals from the resin part of the composite material of the wind blade. Then we have the cloud traceability platform, which is the blockchain tool. Then the eco-design strategy to have the added value for the final product to reach the market, which is this approach will start just after the project end. We have also the 3D printing for new processes and technologies for the additive manufacturing. And lastly, the optimized composite materials for an infrastructure application in the non-structural component. All these activities will start from the project end in about 3 to 5 years after the project end. So thank you for the attention. Sorry for my voice. We have the sorry.
Thank you, Daniel.
We have
Thank you, Daniel.
okay, yeah, my contacts and that's all from my side.
Thank you. Now we will go on with the next project, always in the wind power field, and will be presented by Gloria Carallo, and the name is Mare Wind.
Thank you, Michela, for the introduction. Thank you. I will share my screen. Okay. You can see my presentation.
Yes.
Okay, thank you. So, good morning, everyone. I'm Gloria Carallo, and today I will introduce you Mare Wind project, which is a project funded under European Horizon 2020 program. The acronym of Mare Wind stands for Material Solutions for Cost Reduction and Extended Service Life on Wind Offshore Facilities. So the goal of this project is mainly to design and produce new materials, coatings and multi-materials structures for the wind offshore energy sector. The coordinator of the project is Lurederra, which is a Spanish foundation for the technological and social development. And the project includes 16 different participants from 7 European countries, among which China is one of the WP leaders. The project has started in December 2020 and it will last 48 months, so it will end the next year. The main topics related to Mare Wind projects are composite materials, wind power, coatings, recycling and corrosion. Among the objectives of the Mare Wind, we have, first of all, the increasing durability of new materials developed during the project. So, first of all, the project is related to the anti-corrosion protection for metallic structures exposed to marine environment, as well as also an increase of durability for concrete structural components. Then anti-fouling coatings are also developed during the project without the addition of biocides, so in a sustainable perspective. And also another important material developed during the project is composite with for the wind turbines. So in this case, the objective is to increase the stiffness and strength while reducing the weight of these structures. And then also an increase in the production of coating materials for their resistance to erosion. Then also in addition to materials, we have also processes that are improved during the project. For instance, the development of structural health monitoring techniques for wind offshore turbine. Then some predictive models have been developed during the project for the corrosion protection. Recyclable by design is one of the approach developed during the project for the wind turbine, as well as a recycling procedure. Then all the technologies developed during the project should be scalable at the end, and also an application of existing standards for this kind of new materials has been targeted during the project. Finally, but not the least, also economical, environmental and societal viability of all these proposed solution is assessed along the project duration. Then, among the expected impacts of Mare Wind project, we will have, of course, the increase of the durability of new materials developed during Mare Wind. So, both composite materials for the wind turbine, as well as the corrosion coating, anti-corrosion coating, the structural concrete, reinforced concrete, anti-fouling coatings, and anti-erosion coating target to have an increase in their durability with respect to the standard baseline that it is available at this moment. not only so the material perspective, but also the cost point of view. And then in order to reduce also the maintenance of this structure along the years, another expected impact is also to reduce the life cycle cost of all the structure during its lifetime. Then also the cost reduction of offshore energy production, so this is an indirect effect but also accounted for the project, and the reduction of environmental impact. At the same time, also reducing CO2 emissions and fuel dependency is one of the expected impacts. And another indirect but important spin-off of the project is also to create growth and jobs in Europe about marine and energy, wind energy environment. So at the strategic level, MareWind take cue from European wind energy sector trends. So as we know, Renewable Energy Directive aims to increase the share of energy, of renewable energy by at least 20% in the next years, as well as the study of the European Commission set as an increase in the production of wind energy to 550 gigawatts by 2050 as targeted by European Green Deal program. Another important study of Wind Europe, which is an association related to the wind power, set as an increase of 7 gigawatts of energy, wind energy until 2030, and so a constant increase year by year of the production of wind energy. Of course, some challenges are related to the wind offshore energy nowadays. So first of all, the use of materials that don't suffer the damage during their service life because of radiation, wetness, and abrasion is one of the most important targets that also have a relevance and importance in the reducing the operation and maintenance costs related to to this production. Of course, as anticipated also by Teresa and Michela, service life, the end of life, of the composite materials is one of the most important challenges at this moment, because we have not so efficient procedure for their decommissioning, and so also the turbine blades should receive attention in this case, and it is one of the MareWind objectives. And finally, also the social acceptance of marine and energy, wind energy solutions is targeted and also is increased during the project. So the methodology of MareWind starts from the requirement that energy sector has experienced in the last years, and Europe in particular is now leader of wind market. So the aim of MareWind is to increase the durability and recyclability of their materials, improving also the monitoring and reducing the necessity of maintenance in order to obtain a sustainable model for the offshore wind sector. The strategy proposed by MareWind is threefold. First of all, we have the materials development and improvement. Then we have the manufacturing of prototypes and their testing in relevant environment. And finally, the monitoring and validation processes. First of all, so from the materials point of view, we have the production of new composite wind blade. First of all, the introduction of silica nanoparticles improve the durability in marine environment. Then another important topic, as anticipated, is the recyclability of composite materials, and in this case CETMA proposed a new system, a new methodology in order to recycle GFRP structures at the end of their service life. Not only recyclability, but also an efficient production process. In this case, EIRE, which is the blade manufacturer, set up a tooling process, an advanced tooling process that allows for a cost-effective and sustainable production, so without the use and emission of VOC. Another material developed during the MareWind project is concrete. In this case, two different formulations are developed during the project. The first one is from Acciona. In this case, an ultra high performance concrete is designed in order to have an increased resistance to water penetration. The other system instead is proposed by CETMA again, and this is an alkali activated material concrete with a cement-free formulation. So both the system has an higher durability and also an eco-friendly formulation in order to meet the sustainable requirements. In conclusion, for the material perspective, we have three different kinds of coating. The first one is developed by Lurederra, and it is an anti-corrosion coating with low no chrome addition, so a sustainable formulation. The second one is also developed by Lurederra, and it is an anti-fouling coating. In this case, as anticipated, we don't have the use of biocides, so and also the room curing temperature allows for a low energy consumption process. And finally, anti-erosion super hydrophotic coating developed by TWE is a polyurethane-based coating without the addition of, in this case, also metals, and has a very high contact angle, so an increased rain erosion resistance. After the materials formulation, we have also the development of prototypes and testing in relevant environment, which allows for the identification of criticalities or also other specific features with which have to be corrected and improved along the project. Besides the testing in relevant environment, the finite element method models developed by Rina and Inegi helps the prediction of mechanical properties before the testing in relevant environment. So it is an important tool in order to understand the behavior of these materials. In addition to that, also the multi-scale model, MODA, helps to understand the characteristic of materials along their testing over time. After the project end, the objective of MareWind are, of course, to increase the penetration of these materials over the market, the recyclable solution on the wind energy sector. Of course, among the objectives, there is to meet the European climate target and create new job opportunities in the wind industry, to improve the sustainability in materials and processes related to the wind offshore sector, to upscale the production and the diffusion of these new products in the marine, but also in other correlated sectors in which these products and materials could be object of interest, to promote the developed methodologies, for instance, structural health monitoring and predictive modeling that are developed during the project for marine and wind sector, to increase the awareness and interest in new technologies for a sustainable world, in this case conferences and any other dissemination activities is performed and will be performed also at the end of the project, and also to promote the basic research all around Europe towards new sustainable materials and processes for the wind offshore sector. Of course, MareWind is a social project, so here you can find the contacts of the project coordinator, which are Mrs. Marta Mateo and Mrs. Cristina Salazar from Lurederra. We have a website in which you can find any additional information about the project activities, and of course also on the social media, on LinkedIn and Twitter and YouTube, we have our project channel in which also it is possible to subscribe for updates and for the newsletter. This was my last slide, so here are my email and the indication of the MareWind website, and I thank you all for your attention. Thank you.
Thank you, Gloria, for the presentation. It was very interesting. The next panelist will be Paul Duncan, that will present Rare Square project. Paul, the floor is yours.
Okay, thank you, Michela. And yes, as my colleague said, I'm Paul Danca, and I don't see okay. And I'm a system engineer here in the Innovation System Engineer Division in RINA. And today I will be talking to you about the Rare Square project, which stands for Human-Centered Rapid Reconfiguration of production and value chains in fast-changing scenarios. This project has received funding from the European Union's Horizon program, and in total for 8.4 million euros budget. And those are co-funded between 60 to 100%, depending on the single company. In particular, RINA has received a 60% funding, and the duration of the project is expected to be 3.5 years. The project just started, so we are still in the first phases. And as you can see, the consortium is composed by 22 European partners, which range from industries that have manufacturing chains, from certification organizations like RINA itself, and we also have some academic partners to help us develop the product. And the idea behind the RARESPEC project is that to enable the creation of a sustainable and resilient European manufacturing ecosystem that can swiftly adapt to unforeseen market shifts, sudden disruptions, or regulatory modifications in many scenarios. And I think the best example is the recent disruption that came with the corona spread. What is for these systems to have the capability to rapidly achieve their maximum production efforts in the fastest way possible. This will be done through the implementation of a holistic ecosystem platform, which with the help and the collaboration of many European organizations wants to receive as an input many informations, many data about regulatory status, standards, protocols, but also technical data about the technical processes operating in these manufacturing processes, and to give as an output optimal solutions for, as we said, the reconfiguration in case of disruptive changes, but also for general optimization for those companies that already have an operating process. In general, the project will focus on 5 main themes, which are the platform itself, which will be the kernel of the project. We'll deal with early detection, because this platform does not only want to help in the reconfiguration in case of disruptive changes, but also to try to predict them with the use of, for example, AI technologies to give better results in case these disruptive changes happen. It will focus on digital twins, because to give these suggestions on reprocessing, on reconfiguration, it will need to understand how these processes work, and this will be done with the implementation of digital twins. It will deal with workers, and in particular with their skills, because it would be useless to give proposed solutions if there is not the base workforce able to implement these suggestions. Also, and finally, it will deal with the creation of a resilient European ecosystem that through the by interfacing many companies and organizations with each other can provide the best solutions in case these disruptive changes do happen. In particular, the RARE Square project will be divided in 3 main phases. The first phase is the preparation phase, during which requirements, possibilities will be analyzed, also considering technological and methodological requirements and legal constraints and technical peculiarities. Then we will have a second phase, which is the technology development phase, during which a first version of this holistic ecosystem platform will be developed, and its main components will be connected to a security platform. And finally, this will all serve for the third phase, which is a demonstration phase, during which, through the help of some demonstrators within the consortium, the platform will be fed with real data coming from a real industrial environment and will be validated in order to prepare it for commercial exploitation and integration in the European ecosystem. In particular, regarding this demonstration phase, we have 4 demonstrators within the consortium, and they all operate in different sectors. They have different needs, and they have different objectives that we expect this holistic platform to help them achieve them. And for example, we have our first demonstrator, which is MMM, which mainly deals with machinery for processing of medical devices and modular buildings which do that. And their main goal is to, in an optimization way to looking at it, to better understand the standards and the protocols that are operative in neighboring countries, and to increase the versatility of their modular buildings in order to expand their market. And our second demonstrator is Carvala, which mainly produces child hardware like strollers and car seats with injection molding technique. And for example, they would like to have a better understanding of which equipment can be used better than it is now used, which materials could be used instead of the ones they use nowadays, where to find these materials in case a sudden market change happens, and in general to minimize the skill gap required to work in these processes. Our third demonstrator is Fontana, which mainly deals with dice manufacturing and stamping of metal parts for luxury and sport cars. And they would like also at this stage to, for example, optimize the space their assembly line requires. They would like to reduce their costs and to increase the number of projects that they can deal with simultaneously. And the last demonstrator is Manicon, which deals with the manufacturing of contact lens, which is a very specific sector. So again, the possibility to change sector in which to operate after disruptive changes is not the only feature that this platform will have, but for example, in their case, they would like to enable machine monitoring in order to predict and as such act quickly if any incidents occur, to apply smart logistics and to predict lens quality. And all these goals these different demonstrators have are just to give an idea of what we expect this holistic platform will be able to do. In particular, at the end of the project, we expect to have improved a wide range of production steps that will also consider logistics, non-manufacturing operations, and other factors that can facilitate the production run. We expect to decrease the time required for reconfiguration activities and the reconfiguration also of individual production steps that can improve the overall performance of the production line. We expect to have understood and established some protocols for optimal practice in rapid reconfiguration, which we would like to be usable and transferable in many sectors. And also we would like to create verified standardized interfaces and protocols in order to empower the digital and flexible manufacturing processes. And all of that, we, for the nature of the project itself, we think that would be best achieved with the international cooperation, in particular with the realities outside the European zone, like Japan, South Korea, and Canada, because the recent events have proved how the world is more interconnected than everyone was expecting. And for me, this is all. I'd like to thank you for your attention. Here are my contacts and the site of the RareSquare project. And if you have questions, please don't hesitate to contact me.
Thank you, Paul. Now it's the time of the next speaker, Enrico Salvatore, which will present Hephaestus project. Go, Enrico, the floor is yours. We cannot hear you.
Can you hear me now?
Yes.
Okay. Hello, everyone. My name is Enrico Salvatore, and I'm the project coordinator of Hephaestus project. The Hephaestus project is the Hephaestus project is an European-founded project and aims to develop a scalable and tunable solution to effectively treat waste derived from primary mining and metallurgical streams. Within the project, we are developing several different units to transform the dust from electric arc furnaces into metal alloys and to recover zinc. Also, there will be units for catalytic conversion of carbon dioxide. 2 prototypes demonstration are planned in Greece and in Italy, and the scale, target scale for this prototype is around 10,000 tons of waste dust per year. The project is divided into 3 countries, Italy, Greece, and Belgium, and with both industrial partners and engineering and consulting partners, and also university and research centers. The duration of the project is 4 years, and it started last year in June, so we still have 3 years ahead to go. The technical solution of the project consists of the following operation units. The first one is the cleantech furnace, which performs the carbothermic reduction of the electric arc furnace fine dust, and this produces the eco alloys ingots, a slag that can be used in the subsequent fiber unit operation, and it also produces secondary dust. The secondary dust are those that will be processed with the the second operation unit, which is the EDSINEX process. And this process is an innovative hydrometallurgical process for the complete recovery of zinc. The third unit operation is the fiberization line to transform directly the molten slag into mineral wool. The third operation unit is the carbon capture technology to produce methanol from the off gases of the electric arc furnace. And the last unit operation are the ones involving the innovative hydrometallurgical process, ammonia, ammonium carbonate, and metasulfonic acid to completely recycle zinc and iron-rich residues. The key objective of the project is indeed to develop a set of scalable and tunable operation units to be built as integrated process plant that are able to treat multiple process waste deriving from two main streams of metallurgical waste. The first one, waste deriving from steel industry, in particular the dust coming from electric arc furnace and argon oxygen decarbonization processes. Those wastes represent a large volume that has to be taken care of, and those days represent a huge amount of dust per year to be disposed, with a cost of 200 euros per ton of dust to be disposed. The other streams of waste are those coming from mining and extractive industry that are unavoidable due to the processing of cutting and crushing. The target scale application is around 10,000 tons of waste dust per year to cope with a typically fragmented European process size. Globally, the project aimed to reduce 0.8 megawatt-hour of energy consumption and 3 tons of carbon dioxide emission against the current practice. The project will be verified against four macro technical objectives. The first one is assessment of potential sites for the project implementation. The second one is the setup of virtual plant layout in order to perform analysis for technological and economic and environmental feasibility. The third is the construction of the pilot site and the verification of the solution at TRL 7. The fourth objective is to demonstrate the industrial suitability and the global sustainability of the two applications. Hephaestus project is expected to significantly impact the whole iron producing facilities, focusing on increase of profitability of secondary steel smelting, increasing the utilization factor of electric arc furnace, and minimizing the impact of waste. The results are also assessed with measurable indicators, such as the waste reduction, with approximately only 58 kilograms of inert waste derived for each ton of fine dust processed. The emission reduction of approximately 300 kilograms of carbon dioxide per waste of materials. And this number can be further increased considering the volume of carbon dioxide that can be captured and transformed into methanol. And the last parameters is the energy consumption reduction against the traditional processes. Then at the end of the project, exhaustive techno-economic analysis will be based on the results of the pilot test to perform and quantify financial sustainability of the solution. The project is organized in order to meet the European climate and energy target for 2030, and also contributes to respond the oncoming limitation to landfilling to reach the objective of a European Green Deal. In particular, the following aspect represents the target and has to be considered, and are a reduction of carbon dioxide emission, recovery of waste, and the reduction of landfilling, saving of new raw materials. In fact, thanks to the utilization of almost the totality of the waste, 8.6 thousand tons of metal alloy can be fully recycled to the steel industry. Additionally, other non-renewable minerals that are necessary for the formulation of mineral wools can be avoided. And of course, there is the savings associated to the recovery of zinc. Another parameters is the reduction of the energy consumption. The energy consumption associated with the production, the reduced production of raw materials, and also there is an energy savings coming from the fact that the mineral wool is produced directly from the molten slag. So the two processes are coupled in order to saving from remelting again the slag. And also we have to consider that thanks to the capability to recover the metals, even though no selectivity is implemented, the process is extremely effective in recovery all metals, and therefore also the critical raw materials. The Hephaestus project is organized in 8 work packages. The first 2 concern the material and the process requirements, market, the creation of the roadmap, and the assessment of waste and European sites. The work package number 3 and 4 are those related to the realization of the pilots with the process modeling and design. The work package number 5 is the creation of the implementation of the 2 demo sites, the demonstration and validation. While there are other 3 work packages that cover the entire duration of the project, and are the work package 6 with the sustainability assessment for the economic, socioeconomic, and environmental sustainability assessment. Work package number 7 with concerning standard dissemination, communication, and exploitation of results, and work package 8 with the project management. Finally, we expect to reach the target and to calculate the capacity to reach the target at the end of the project and after 5 years from the end of the project. We estimate that the partners, in 5 years, the process should be implemented and replicated in at least other 5 steel mills. And we also considered 4 exploitable results. The first one is connected to the integrated pilot plant to convert for the conversion of mineral, the creation of mineral wool, and the production of metal alloy and recycling of zinc. The second result that can be exploited is the process connected to the carbon capture and transformation. Then there is the hydrometallurgical processes that, even though that they are a lower TRL, they can be directly attached to the main system. And finally, there is the formulation of waste matching the circular products needs. And that concludes the presentation. Thank you for the attention.
Thank you very much, Enrico, for the presentation. This was our last presentation of today. And I want to conclude this meeting saying that, as you can see, there are several more innovative or less innovative solutions to increase the sustainability. I hope that in some way we inspire you to improve the sustainability in your processes, in your companies. And I want to conclude showing you this slide, which are our contacts, to invite you to contact us in case you have any question that today I see there is no question in the box, but also if you have any idea for collaboration, if you want to know more about how RINA can help you to improve your sustainability, you are welcome to contact us every moment. Thank you everyone, and I wish you a nice day. Thank you also to all our speakers. Bye.
Bye, Michela. Thanks to you.